Hey guys, in this video I'm going to go through a quick summary of composite functions, a topic that was requested by one of our new Facebook group members. Now, in this video I'm going to go through only the theory part and explain what you need to know and show you the steps on how you can approach composite function questions. In the near future I'll upload videos going through some example questions and how to approach them. Better yet, if you have any specific composite function questions, post them here in this group and I'll create a video tutorial for it. Now basically, a composite function is a function that is written inside another function. So let's say if we have two functions, f of x, and this is equal to 2x plus 3, and g of x, and this is equal to x squared. The notation used for composite functions is written as f of g of x or g of f of x. For f of g of x is the inner function and f is the outer function. For g of f of x is the inner function and g is the outer function. An equivalent notation to write f of g of x is writing it as f and then a little o and then g and then x. And for g of f of x, we can write this as g and then little o f of x. This is commonly read as fog and goff. One thing you need to note here is that f of g of x does not always equal g of f of x. A composite function, whether it's f of g of x or g of f of x, can either exist or not exist. So what does it mean for a composite function to exist or not to exist? For a composite function to exist, it means that the range of its inner function is equal to or a subset of the domain of the outer function. To check if the composite function exists, you need to draw a table and write down the domain and range of each of the functions, both the inner function and the outer function. And then reading from the table, if the range of the inner function is equal to or a subset of the domain of the outer function, then we can say that the composite function exists. The domain of this composite function is then going to equal to the domain of the inner function. If a composite function does not exist, in other words, it's not defined, then the range of the inner function does not equal or it's not a subset of the domain of the outer function. To make a composite function exist, in other words, make it defined, what you need to do is change the domain of the inner function such that the range of the inner function with its new domain equals or is a subset of the domain of the outer function. To do this, you'd need to sketch the graph of the inner function and then, looking at its graph, restrict the domain so its range is equal to or a subset of the domain of the outer function. Once you have changed or restricted the domain of the inner function so the composite function is now defined or exists, the domain of the composite function is now going to be the restricted domain of the inner function. And if you were asked to state why a composite function does not exist, all you need to do is write down, using interval notation, the range of the inner function does not equal or is not a subset of the domain of the outer function. And finally, how to find the range of a composite function. Generally, when we need to find the range of any function, we sketch its graph for the domain it's defined in, and then looking at the graph we can determine the range of that function. To find the range of a composite function, we do the same. The only difference is that depending on the rule of the composite function, we sketch a different graph. Once you work out the rule of the composite function, you need to ask yourself, is this a function that you've been taught how to sketch? Like, is it a parabola, or a square root, or a hyperbola? And if it is, then all you need to do is sketch the graph of the composite function. Just be careful when you're sketching the rule of the composite function that you sketch it only for the defined domain. And we already learned that the domain of the composite function is equal to the domain of its inner function. You then determine the range of the composite function from its graph. If the composite function had a rule that you had not been taught how to sketch, for instance, the log of x squared plus 5, or the square root of x cubed plus 10, or something crazy like that, then you can ignore the rule of the composite function. What you need to do instead is first find the range of the inner function. Once you've found the range of the inner function, then you need to let this range become the new domain of the outer function. You then sketch the outer function with this new domain. So you're not sketching the rule of the composite function, you're just sketching the graph of the outer function, only this time with this new domain, which is going to be the range of the inner function. The range of this outer function is then going to be equal to the range of the composite function. And just as a side note, you could even use this second method even if you knew how to sketch the composite function. It's just a better method when you end up with a harder function to sketch. Also, if the composite function has a rule that you have not been taught how to sketch, but you're allowed to use your CAS calculator, you can also use the first method to find the range, since you can use your calculator to graph the composite function. That's pretty much it for the summary of composite functions. If you guys want to have a better grasp of the topic and learn how to answer composite function questions, then log into the Maths Methods Club, and from the main topic select Functions and Graphs. And then from the subtopics select Composite Functions. Here you'll find all the composite function questions asked in the previous exams. Watch the step-by-step videos and learn how to approach these types of questions. That's it for this tutorial. If you have any questions, leave your comments below. Good luck, and I'll see you guys in the next video.